Hey, 7th grade, here we are in chapter 7. This is lesson 5, all about something called the triangle inequality formula. And I'm going to tell you something. This blew my mind the first time I learned about this. I will tell you, I think this is such a fascinating relationship among triangles, and I think you will be interested in it as well. So let's get started with a little bit of vocab. On your notes, you have a triangle. I want you to label it like this. The two short sides, we're going to call them legs, and the longest side, we're going to call the hypotenuse. Okay, so these are some of our key vocab for this lesson, and let's talk about our notes. Every triangle has two short sides called legs and a long side called the hypotenuse, and that's what we just labeled here. Remember from the previous lesson, we learned that the longest side sits across from your largest angle. So if you're ever wondering which side is the biggest, take a look at your angles, and that might help out a little bit as well. Today we're talking about something called the triangle inequality theorem. And the triangle inequality theorem helps us determine whether three side lengths can be used to construct a triangle. And what that means is we can't just take any three measurements and build a triangle with it. And that's something that I think I never knew when I was in 7th grade. We have to actually have three side lengths that have a mathematical relationship before we can build a triangle with them. And that mathematical relationship is this triangle inequality theorem. And this inequality theorem says that the two legs of a triangle have to add together to be greater than the hypotenuse. Okay, so we're going to use a formula when we solve these problems, and that formula is L plus L is greater than H. Make sure your L's are written in cursive because a lowercase print L looks like a number 1. Okay, so we've got some examples. Our first question here is, can a triangle be constructed using the side lengths 8 inches, 25 inches, and 12 inches? So basically we're saying if I have 3 sticks and one measures 18 inches, the other measures 25 inches, and the third measures 12 inches, could I use those 3 sticks to make a triangle? And that's what this lesson is all about. So the first thing we have to do is find our hypotenuse. And the hypotenuse is the longest side, so I'm going to put an H over the number 25. The other two sides are going to be the legs, the two short sides, and it is important that we pick this out. Then we want to write our formula. Leg plus leg is greater than the hypotenuse, and we're going to take these two values for the legs and we're going to substitute them in for our two L's. 18 is our first leg, 12 is our second leg, and the hypotenuse is 25. So we've written an inequality, and we need to take this side and simplify it to see if it's a true inequality or if it's a false inequality. 18 plus 12 is 30. So we are left with 30 plus 25. And that is a true statement because 30 is greater than the number 25. So because we get a true statement here at the end, we know that yes, we can build that triangle with side lengths 18, 25, and 12. Pretty easy, right? Let's take a look at this one. A triangle has side lengths 4m and 10m. What is the range of all possible lengths for the third side? So this is where we're not just looking, hey, can we build a triangle? We're looking for all the measurements that can be used to build this triangle with these two starting pieces. So we're going to actually have to do two problems here. Our first problem is going to treat these two measurements as if they were legs. That's going to tell us that we are looking for our hypotenuse, and that's going to give us the upper part of our range. Then we're going to solve it again in a little bit of a different way. So formula is leg plus leg is greater than the hypotenuse. We're calling 4 and 10 both legs. And we're going to leave that h a variable because we're solving for it. 4 plus 10 is 14. So we get 14 is greater than h. Remember, we like to have our variable on the left for these, so we're going to do the flip, flip, flip. Get the h over here. We flip our inequality sign, and we bring our constant over as well. So our final answer here is h is less than 14. So the hypotenuse has to be smaller than 14. Okay. Over here, we're going to solve a little bit of a different problem. Instead of these both being legs, we're going to let the smaller one be a leg and the larger one be the hypotenuse. And our formula is leg plus leg is greater than hypotenuse. One of our legs is 4 and the other leg is unknown. That's what we're solving for now, that missing leg. 10 is the hypotenuse. So we have to solve this inequality, subtract 4 on both sides, and we get L is greater than 6. So the range of our possible side lengths for the third side is that it would have to be larger than 6 and smaller than 14. Larger than 6, smaller than 14. So you could turn this into an answer and do only whole numbers. The number larger than 6 would be 7. A number smaller than 14 is 13. So we could say that the range of all of our possible answers are 7 meters through 13 meters. Okay, 6 would not be a possible answer. It has to be bigger than 6. 14 is not a possible answer. It has to be smaller than 14. So that's where I got those two numbers from. All right, last but not least, Matthew has 2 Twizzlers, each measuring 9 inches long, and a third Twizzler measuring X inches long. Name a value for X that could not create a delicious Twizzler triangle. So again, we have some flexibility here, but basically we're saying we have 2 9-inch pieces and a third piece that is unknown. And we want to know what value can we put in for X that would not create a triangle. So we'll call these the legs, and we'll call this the hypotenuse. So leg plus leg is greater than hypotenuse. Our 2 legs are both 9 inches long. We don't know the hypotenuse yet. 9 plus 9 is 18. And we're going to do the flip, flip, flip. So in order for us to create a triangle, we would have to have h less than 18. So if we pick anything greater than 18, it will not create a delicious Twizzler triangle. So I'm going to say my third side can equal 20 inches. And that would not create a triangle. So I picked something so that it would not work. Okay? All right. Play around with this. Take a look at these. Definitely spend some time on those practice problems and bring questions to class tomorrow that we can talk about, because this is a really cool lesson. I really like teaching this one. All right, go ahead and do your practice problems. We'll talk in class tomorrow.